In this lesson, we're going to talk about Zener diodes. But to begin, let's compare the Zener diode to a conventional diode. On the right, this is the symbol for a Zener diode. Now, a conventional diode is designed to allow conventional current to flow in the forward direction. So this would be the positive terminal, and this would be the negative terminal. In a Zener diode, current can flow in the forward direction like a conventional diode, or it can flow in the opposite direction. Now, a Zener diode is designed to operate in the reverse bias mode. In this mode, the Zener diode has a certain reverse breakdown voltage, and it's basically the rating of the Zener diode. So let's say if we have a 12 volt Zener diode. So when you place it in reverse mode, if the voltage is 12 or more, it will conduct in that direction. So let's give some examples. Let's apply it to a typical circuit problem. So let's say we have a battery and we have a current limiting resistor in series with a Zener diode that's in reverse mode. Now let's say the rating of the Zener diode is 12 volts. And let's say we have a 1 kilo ohm resistor. Now what's going to happen if the battery is a 5 volt battery? What is the current in this circuit? Is the circuit on or is it off? Now, because the input voltage of the circuit is less than the reverse breakdown voltage of the Zener diode, no current will flow in this circuit. So the circuit is off. The current that's flowing in this resistor is 0 amps. Now let's say if we connect a voltmeter across the Zener diode, what voltage will it read? Now because there's no current flowing in the circuit, the voltage across the resistor is 0 volts. So therefore the voltage across the Zener diode that will be picked up by a voltmeter will be the same as the voltage of the battery. It will be 5 volts. Because these two, they have to add up to 5. So now let's use the same circuit, but this time we're going to increase the voltage of the battery. So let's make it, in this case, 14 volts instead of 12 or 5. Now, is the circuit on or is it off? Because the input voltage exceeds the reverse breakdown voltage of the Zener diode, the circuit is going to be on. And so there's going to be a current flowing through this resistor. So how can we calculate the current in this circuit? How can we find the answer? In order to find the answer, it's important to understand that the Zener diode serves as a voltage regulator. So as long as the current is around basically the characteristic current for this particular Zener diode, let's say if it's small, it's not too large, the voltage across the Zener diode will remain approximately 12. It might vary a little, but for the most part, for all practical purposes, we're going to say that it's about 12. It could be 11.9, 12.1, but it's going to be fairly constant. So that means that the voltage across the resistor has to be 2 volts, because these two, they have to add up to the voltage of the battery. So we have 2 volts across a 1 kilo ohm resistor. So if we use V equals IR, then the voltage, well, the current flowing through that resistor is going to be the voltage divided by the resistance. So it's going to be 2 volts divided by 1,000 ohms, which is going to be 0.002 amps or 2 milliamps. So that's the current that's flowing in this circuit. But it's important to understand that the Zener diode will maintain a relatively constant voltage of 12 volts when it's in reverse bias mode, and if the input voltage exceeds that value. That is the rating of the Zener diode. Now let's increase the voltage of the battery. So let's use the same circuit with the same components. So we have a 12-volt Zener diode, but this time let's use a 50-volt battery. So what is the voltage across the Zener diode? And what's going to be the current in the circuit? In this case, the voltage across the Zener diode will still be approximately 12 volts, which means the voltage across the resistor has to be 50 minus 12, or 38 volts. So if we take 38 volts divided by 1 kilo ohm, that will give us a current of 38 milliamps flowing through that resistor and through the entire circuit. So that's how you can easily determine the current flowing in such a circuit whenever you have a resistor in series with a Zener diode. Now there's a lot of other stuff that we can do. So here's another circuit. Let's say if we have a 50-volt battery, and let's use a 1 kilo ohm resistor again, but this time we're going to use 2 Zener diodes as opposed to 1. And let's say the rating for each Zener diode is 12 volts. So what is the current flowing in the circuit now? So the input voltage exceeds the total reverse voltage of the 2 Zener diodes, which means the circuit's going to be on. And so the voltage drop, or the voltage across those 2 Zener diodes, is going to be 12 plus 12. So we're going to have 24 volts across those 2 Zener diodes, which means the voltage across the 1 kilo ohm resistor is going to be 26, because 24 plus 26 adds up to 50. So if we take 26 volts and divide it by a 1 kilo ohm resistor, that's going to give us a current of 26 milliamps flowing in this circuit. But if you want a simple way to calculate the current, it's going to be the input voltage, which is 50, minus the total reverse voltage of the 2 Zener diodes, which is 24, and then you divide that by the 1 kilo ohm resistor, which is 1000 ohms. And so 26 divided by 1000, that's 0.026 amps. And then you can convert that to milliamps by multiplying it by 1000. So here is a generic formula to calculate the current in the previous circuits. It's going to be the input voltage minus the total reverse Zener voltage divided by the resistance in the circuit. And so that'll give you the current flowing in the circuit. Now let's say if we have an AC sine wave connected to a resistor and 2 Zener diodes connected like this. So what's going to happen? Let's call this point A, and let's call this point B, and then we'll call this D1 and D2. So when current is flowing in this direction, notice that D2, the arrow points in the same direction as the current. So in that case, that diode will be in its forward operating mode, which means it'll have a voltage drop of approximately 0.6. And this diode, it's in reverse mode because its arrow is opposite to the direction of the current. So its voltage drop will be 12. So therefore the voltage across A and B will be 12.6. Now, let's say if the current travels in the other direction. By the way, let's say this voltage is greater than 12.6. Let's say it's 20 volts. Now, if the current is flowing in this direction, D2 will have a voltage drop of negative 12 because it's now in reverse mode. D1 is in forward mode, and so the voltage drop will be the same. Thus, if you have such a circuit, you can convert a sine wave, which will look like this, into basically a clamp wave that looks more like this. With a voltage of positive 12.6 at the top and negative 12.6 at the bottom. And so that's it for my video on Zener diodes. Hopefully you learned a thing or two from it, and thanks for watching.